the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
As you mentioned, my name is Adriana Herrera. Fun fact, I was actually a part of the inception of the Living Laboratory as part of my senior design project in 2016, working as a member of the first team to do basic concept design and modeling for green infrastructure practices throughout the watershed of the Stevens campus with Professor Fassmanbeck and Professor Brunel, which now currently exists on campus. So if you walk by, you can check it out. That was completed by other students after my time, but working on paper, so to speak, I had no construction or feasibility of implementation experience, which has led me to my discussion today with you all, where I hope to share the positive impact that green infrastructure can make on a more resilient and sustainable community, but how one must consider all the enablers and barriers that go into the implementation outside of the design and innovation that we all love to dig our brains into. So just a quick background about myself and I guess my journeys to how I got here. As it was previously mentioned, I'm a Stevens alum. I graduated in 2016 with environmental engineering degree. I started my career at TRC Environmental, where I worked as a remediation engineer specializing in groundwater treatment. I managed sampling programs and injection systems for about 3 years. I switched internally within the company to work in their site and land development department, where I worked alongside construction management to integrate and assess stormwater management practices and systems. All the while, I was working towards my master's degree at Stevens with a focus on water resources, which I completed in May 2021. Looking to expand my stormwater management water resources expertise, I joined the WSP team a little bit under a year ago as a water resource engineer, where I currently work with a fantastic team, performing hydrologic and hydraulic studies, designing green infrastructure, and supporting dam rehabilitation work. A little bit about WSP. We have a variety of sectors across the globe with over 37,000 professionals. We're still growing, looking to provide our clients with the best technical expertise of an interdisciplinary approach in an ever-evolving world. As I mentioned, I work in the Water Resources Department, so I'm personally based out of New York City. However, I sometimes find myself visiting offices in New Jersey where I reside, including Morristown and Newark. There are 4 main areas of the Water Resource Department: advanced modeling, where we do inland and coastal infrastructure using programs such as HEC-HMS, HEC-RAS, WAFIS, MIC, SWIM, to assess riverine reservoirs, stormwater modeling, precipitation frequent forecasting, storm surge, sea level rise and climate change. Hydraulic structures engineering, where we assess dams, levees, culverts, bridges for any variety of purposes from rehabilitation into demolishment. Water planning and asset flood mitigation, resiliency, where we assess coastal infrastructure, sea level rise. And the last is water planning and asset management, where we assess infrastructure systems. As you can see, these 4 areas are often integrated within a singular project, as you can have flood mitigation resiliency with modeling and so on with water planning. And assessment can also involve hydraulic structures. We often are designing sustainable solutions for a variety of environmental concerns using these integrated techniques. One such solution practice is that of green infrastructure or nature-based solution. The solution type is becoming more frequently a response to a growing environmental concern of climate change, which has increased storm event frequency, increased storm severity and rainfall volumes, and contributed to sea level rise, leaving many environments at risk. Specifically, urban environments, which typically consist of high impervious areas, are in need of a sustainable and resilient solution, such as green infrastructure, to manage the strain on the existing systems. And this is a current project that is being worked on by WSP. And if some of you will recognize, there's Stevens campus in the middle corner, where we've done an assessment in Hoboken. So why implement nature-based solutions? Beyond water management, nature-based solutions can also improve air and water quality, provide climate resiliency, and benefit habitats. However, within communities, green infrastructure can also reduce infrastructure costs, such as water and energy consumption, promote an economic growth by creating construction and maintenance jobs, and impact the health of the community, providing more green spaces for recreation. Seems like a no-brainer that urban planning should become more sustainable and resilient by incorporating green infrastructure into urban development. However, we do have to balance novel design concepts such as constructed wetlands, rain gardens, porous pavement with the reality of planning and construction barriers. Furthermore, how do we meet our clients' needs with the consideration for their own limitations in terms of funding and space? So general barriers to green infrastructure, there are some general limitations that take the form of technical and physical, either lack of knowledge or lack of conflict in space, legal and regulatory conflicting laws or not enough regulation guidance, financial impacts where the misperception of costs or lack of data to counter otherwise, and then community institutional perception of the benefits and implementation of green infrastructure. A survey was conducted approximately 5 years ago in 2017 as a part of the Urban Water Journal, which quoted the following responses from a variety of land and facility owners, investors and developers, planners, and consultants in reaction to a reality of implementation of green infrastructure. The red indicated like a socioeconomic political barrier. The black indicated a physical technical barrier, and the blue indicated a combination of them all. Developers of urban communities are sometimes unaware of the benefits of green infrastructure. And even if they are, as you can see by the chart, they are often find it hard to reconcile the infrastructure approaches with building codes and standards. Many of these strategies for overcoming these barriers require action by local governments and municipalities, who in fact actually are in a key position for promoting green infrastructure development on a larger scale, but they are the most affected by more complex challenges and misperceptions as I've described on this slide. So green infrastructure implementation approach. How do we, as a hired consultant, then steer our client in the right direction to ensure a sustainable and resilient solution that prepares for changing conditions, resists or withstands stressors, recovers positively from excess strain, and provides socioeconomic and environmental benefit by taking into account an interdisciplinary approach, understanding the need for green infrastructure through risk assessment, exposure, sensitivity, and adaptive capacity, strategy development, determining a strategy that is resilient to barriers through analysis of responses and recovery, understanding the hazards mitigation, planning and policy making, making sure that that strategy aligns with not only your regulating governing bodies and appropriate permitting, but also with your key stakeholders, both internal and external. Funding, ensuring to understand all appropriate funding sources that would alleviate community barriers that perceive green infrastructure as expensive, understanding how to invest your prioritization across the green infrastructure practices, and then the funding mechanisms, short-term, long-term capital funding of the municipality or developer themselves, or applicability for federal and grant funding. And then lastly, which is probably all of our favorites, is the actual design implementation. Understanding the 4 prior that I discussed about and developing an integrated approach to incorporate all of those aspects makes the design process a lot smoother, and the coordination of construction a lot easier. However, this is on paper and all is easier said than done. I'm going to go through a project example that exemplifies the development of green infrastructure solutions in response to an increased flooding resulting in strain on their existing system through the lens of this outlined approach, to exemplify how barriers arose throughout the project, how our team accounted for those barriers, and how we're still dealing with those barriers today. And then how we can hopefully hurdle those barriers that we're currently exhibiting to not cause a hindrance on our own design and creativity. So the project that I'll be discussing today is the Stevenson Brook watershed analysis. The city of New Rochelle has experienced frequent and severe flooding in the past few decades due to undersized drainage pipes or just a lack thereof. It has negatively impacted multiple of their businesses and their transportation sector. They have identified flooding hotspots or areas of concerns through business complaints, residential complaints, a variety of public flooding data, and then imagery and news sources from the media. We've been provided with these data points, as you can see on the map. There is about approximately 105 of them. Within the past 2 decades, the city has taken strides to implement drainage infrastructure projects, including pipe repair and a limited amount of retention basin projects. However, their localized Band-Aid project, improving conditions, was not beneficial for their economic long-term capital funding plan. So they have looked for improving conditions and creating integrated watershed-based plan to address on a more cost-effective mitigation strategy. So the Stevenson project is an example that focuses on inland flooding, water planning and asset management, and also advanced modeling for flood depth. The study area is mostly residential and commercial, including some public administration, professional and technical services. The area contains a few water bodies, including 2 critical facilities identified by FEMA, which is Payne Lake Dam and Huguenot Lake Dam. So for vulnerability and resilience assessment, the risk assessment was performed for the Stevenson Brook prior to the commencement of the project. It conducted with a data review and field reconnaissance. Variously publicly available institutes, including USDA, FEMA, NOAA, USGS, Westchester County, and then the New York State DEC were utilized for additional data acquisitions on top of client-provided materials. The field team assessed each location with a field reconnaissance to determine the topography in relation to the drainage inlets, the catch basin locations, and the number and quality of infrastructure catchments, and also to determine the existing system routing. The initial review allows for clear communication and engagement with the community and other stakeholders to avoid any negative or misperception barriers. Throughout the field reconnaissance, our team, as always, whenever you enter a job site, receives a lot of public scrutiny. So you need to make sure that you understand when talking with the public, that you understand and get their opinions and views of the situation. And also it's best to work with management and the client as how to proceed with communicating with public engagement. In this case, the review was proved especially beneficial since during the reconnaissance, we discovered that the existing client data provided in the slide showing pipe and drainage infrastructures that a huge majority of the existing storm sewer connections, slopes, inverts were missing. Now, without this initial vulnerability and resilience assessment, we would not have been able to determine where to site green infrastructure, where to model our hydraulics without that missing data. And that would have been a technical barrier that our team would have encountered. We then sent out an additional field data collection with a sub-consultant to survey this information. So our strategic approach is in response to the desktop data review that we've collected through publicly available resources, field reconnaissance, without doing any real nitty-gritty modeling or data analysis. The review gives us, the engineer, the designer, a better understanding of the reality of the real-life conditions and to aid in how we're going to approach our data analysis, which will in turn determine the scope of the green infrastructure incorporation throughout the watershed. We have taken a three-phase, pronged approach. Our phase one is of the study consists of the data collection and field reconnaissance, which I just discussed. Phase two consists of analyzing all the data into a usable hydrologic and hydraulic model. The model created will allow us to analyze the flooding hotspots and areas of concern and to prioritize higher flood risk zones for more in-depth design. And then our phase three consisted of developing mitigation concepts that will improve the study area's existing drainage system. The concepts are based upon the results of our data analysis, which are based on the quality of our data collection. The plan was developed to provide the city with a variety of solutions, both green, gray, and a hybrid approach that both short and long-term integration can be conducted. During this phase, institutional and community barriers, as well as stakeholder barriers, may arise when the strategic plans of regulatory agencies, the client, and/or the consultant do not align. In this particular case, the client was originally seeking green infrastructure mitigation tactics only, and our strategic plan was based on this. However, because we wanted to ensure that we're providing with a variety of options and responses, it was then, addressed to us that the strategic plan should change to incorporate both green and gray infrastructure so that the city can appropriately provide funding for more short-term solutions, which would be your green infrastructure, to help alleviate until the city can find appropriate funding for long-term solutions for their undersized pipe system. This sounds really quick and simple. However, it took a few meetings, a couple of weeks worth back and forth with the client and all the appropriate stakeholders involved to ensure that this strategic development, this plan of what we're providing them, aligns with what they want and need, as well as I mentioned, their funding sources. So I've spoken a lot about stakeholders, and the key stakeholders would be the client, WSP, City Council, DPW, and the community. Our planning, as I mentioned, and strategic development needs to account for all of these stakeholders' needs and what they're going to be contributing and how they're going to be utilizing this plan and model that we've designed after the fact. I didn't include governing agencies or regulatory agencies in here as a stakeholder, as I'm focusing more on the direct. However, those governing bodies would be included, especially when you're going through a construction phase and you'll need to be applying for permits. This particular project, with planning and policy making, also incorporated that the green infrastructure only be sited in the right of way, which this kind of helps avoid the public versus private barrier, especially when going through regulation policies. So funding, This aspect of the project we have yet to begin, so my slide is a little sparse. However, based on our strategic planning, we already know how and what we're going to be implementing. We want to make sure that we're providing our climate with an investment prioritization, and this goes back to our cost-effective strategy. Sorry. This goes back to how we want to make sure that we're providing them the strategic planning. Excuse me. Let me just reset. We want to make sure that we're providing the client with appropriate cost estimates to ensure that they have all the funding that they need. As I mentioned, they can either go through different finance mechanisms, their own short and long-term capital funding, or their federal and grant applications. In this particular project, we are going through and providing them with a BCA so that they can so that the stakeholders can make appropriate decisions as to which projects throughout the watershed they will be choosing to implement. And now for the fun part that we all love, the project development. Our team has gone through and now beginning to, we have completed our hydraulic, our H&H modeling, and we're assessing the flooding locations, and our team is going through and citing different green infrastructure and hard infrastructure practices. You can see this is an example. It's not a complete design yet of how we're going to be proposing new pipe lengths, new bioretention systems, new underground detention systems, and I'll just quickly go through a brief, I guess, introduction of the different types of solution palettes that our team has assessed. Our team has, with the implementation strategy, gone through overall advantages, water quality, water quantity, cost criteria, maintenance, and then implementation timeline to help the city determine a prioritization ranking, not just from funding, but also for their BCA, for benefit cost analysis. We've gone through rain gardens. We've also gone through grass swales, which, as you can see, the green infrastructure cost is relatively on the lower scale. And I will show that in comparison as we get into more harder infrastructure, porous pavement, the cost starts to increase. The overall advantages for all of these, however, would be reduction in runoff, underground detention, a dry well catch basin, which provides temporary storage to alleviate the system. Our primary goal for short-term projects is to detain as much water so that during the storm, the conveyance is limited. Then we move into our very gray infrastructure, where we are adding additional inlets and also increasing pipe capacity sizes, where this would fall into a more long-term capital funding type work, depending on the city's prioritization and flooding analysis. Like I said, increased pipe sizes, which will help reduce the storm surcharge into the system and minimize the runoff within the roadways. As I mentioned, the Huguenot and Payne Lake are dams within the middle of the watershed that have outlets that could be modified to prevent backflow and flooding. Regional underground detention storage, which we're looking to site in the city's public parks. And then lastly, a modified operation and maintenance plan. Presently, municipalities often deal with the barrier of lack of personnel or time for such large areas to appropriately operate and maintain their infrastructures. And this is not just the case with City of New Rochelle, it's across the board. And our team is looking to modify a maintenance plan along with our proposed watershed green infrastructure plan so that they could complete routine inspections, routine cleanings for not only the green infrastructure, but also their hard infrastructure with the personnel and funding that they have. So as I mentioned, the project development is the fun part that you get to do on paper. However, taking into account the funding, planning and policy making, strategy development, vulnerability and resilience assessment will in turn help you to identify and assess the barriers of technical and physical, legal and regulatory, financial, and community institutional to help your planning and design implementation run smoother. Thank you.